Okay, so this is just an overview of exponential equations. Kind of want you to get used to what they look like. Y equals A, and then in parentheses you'll have a number. And when we're talking about population growth or some population decreasing, something like that, it'll always be 1 plus some percent as a decimal. And x will be the exponent. That's why it's called an exponential equation. Your x is the exponent. It's a good way to remember it. And x represents time. So A, the number in front of the parenthesis, is always what you're starting at. If you're talking about money you're putting into an account, then that amount of money would go there. If you're talking about your starting population, that would go there. How much medicine you took at a certain time, the amount would go here. Inside the parentheses, it's really important to recognize if it's increasing or decreasing. If that number is greater than 0, then it's increasing. I'm sorry, it should be greater than 1. My apologies. And if that number is less than 1, it's decreasing. So let's look at the first one. We know we started with 300 of something, and if this number is bigger than 1, we know that it's increasing, and this represents some time period. So it could be something like, I have $300 in a bank account, and I am getting 5% interest, because remember, if I take away 1 from 1.05, then that is 0.05, and if I change it to a percent by multiplying by 100, I get 5%. So that is how I know that it's 5%. It's whatever this number is minus 1, and then you times it by 100. And it could be every month that I get interest. It could be every year. This will change. The time period will change, but it always represents time. So let's look at a few more. Y equals 5.3 times 0.97 to the x. We'll notice that this number is less than 1. That means I'm decreasing. So I could have 5.3 million people in a city, and I'm losing 3% each year. Because if I'm keeping 97%, there's 3% that I'm losing. And I could do that annually, or it could be every 10 years. You have to be careful with the x, because the problem will always tell you what the time period is. It's not always a year or a month. You have to just go problem by problem on that one. So this one, I'm starting at 200. Perhaps I took 200 milligrams of some kind of medicine, and every hour I lose 25%, or 75% stays in the system. So if I put a 5 in for x in the calculator, and I put this problem in, I could tell how much would be left in my system after a certain amount of hours. The last one, 10,000 times 1.035 to the x. So something like this could be, I put $10,000 in a bank account, I'm getting 3.5% interest every month or every year. So that's just kind of an overview that you kind of know what each thing means. Remember, if it's an increasing exponential function, it's going to look something like that. A decreasing exponential function, it's going to kind of look like this. So those are the pictures of the graphs. And if you want more details on maybe some problems, then we'll do that at the next one.